Thank you everybody for part of this session. Just to start with, I am part of a JaazX AI group or company which is audible. So I am part of JaazX AI company which is part of Sai Group, which is a bigger company which works on enterprise AI platforms. JaazX is an next-gen AI platform which is trying to solve problems which are related to taking AI to human intelligence, which we typically say as AGI or artificial general intelligence. And using that, trying to solve the enterprise use cases of building automation of complex and judgment-oriented domains. So to start with, this talk actually takes you, or I'll try to brief into the new architecture paradigms which AI is going through. I think a lot of dynamicity at this point. We have seen the Gen AI part of it, which is the generative AI. We have seen the agency part of it, which is the agentic AI. But that doesn't solve the problems which enterprises are looking for to work on real use cases, where AI can take decisions with trust and reliability. So why generation is not enough? So I think it's more than 3 years when ChatGPT launched the initial LLM models, which are using the transformer architecture or generative architecture to understand. It is good in drafts, summaries, recommendations. But it is have a lot of silos into it. In terms of the view it get from the different datas that it need to connect. I'll say the views of policies, views of users who are taking decisions, the use of the internal systems like CRMs or documents. So there is a lot of work that has happened through the different protocols that we see like MCP and all. Still, I'll say it's a more of a limitation, which is kind of an co-pilot limitation, which we use the current generation more as an chatbot or more as a question answering system. So then came the second part of it, which is the agency, where the agentic AI came in, which can take some orchestration of the different agents that we work on, or the different tasks that we work on, or tools. It can interact with tools, it can work as an assistant and orchestration agent, and try to solve some problems, take some actions out of what the generation is providing it as an input. But still, the problem is the silos, and that's where it's a more, I'll say it's not an AI problem, it's also a system design problem, where how to bring it all together. So that's where I come to this maturity curve which AI is going through. Now, this is important for AI to take the next step. So I discussed about the generative AI or generation AI, which produces context, which summarizes knowledge, responds to prompts. Then came the agentic, which call tools, which executes bounded tasks and operates within rules that are defined for it. The next wave is more on the AGI side of it, which I say is the judgment AI, where AI can take its own judgment reliably and trustworthy for the enterprises and automate the things which typically a cognitive mind need to be reviewing, which AI should be able to do. And that is the area where my company works in. So we have, the first two areas are kind of a solved area. There are lot of work going on that area, but the third area is where the things will be going forward as a part of AI maturity. So just from the concept perspective, what I say is AI is a system property, not a model problem as such. Model requires, you can say, maturity, more enhancements, but to solve the judgment problem, you need to bring multiple systems and work them together. So as a part of it, there are 5 pillars that we typically work on. First is the groundedness, which is the grounding, which brings the data. I'll go through this in detail in next slides, but which brings the data to be used for the judgment. And then the reasoning, which is most important. We have seen a lot of reasoners coming up with the thinking models, the reasoning models, which many public hyperscalers have released. But that still have to be customized, that has to be matured and brought up lot of custom reasoners which can help you in judgment at the enterprise level. Then the next are more on the orchestration and memory side of things. I think those are the areas which are getting solved and a lot of research is happening. I'll go in deep on that, how we are working on it and where the industry is going towards it. So for the enterprises, the most important part is having an AI system which is deterministic, repeatable, accurate in judgment with clear reasoning. So if any of this is not there, it cannot take a decision. So it's not a probabilistic model now, it has to be very deterministic. Accuracy has to be near 100 because it will have monetary implications if we are going wrong. So that's where the real work starts for the AI, not the code generation, not the test generation, or not the developer inability. It's more about the actual work that the domain expert or business experts are doing, automating that part. Okay, so from the previous slides, more about what are the different layers that we think of should be part of this enterprise AI stack. I'll be focusing mainly on the colored boxes. It's a generic architecture. You'll have interaction layer, you'll have an agent and runtime layer which takes care of interacting and orchestration of the system. And you have a trust and operative layer, which is mandatory. I have seen many talks which we are going to have is around that, security and all. What I'll focusing on the grounding retrieval or context assembly, reasoning, domain logic constraint and checks, and workflow orchestration. That is very, very important because there are a lot of concepts which doesn't comes at this point when we talk of agentic. And then memory sessions or memory management, which is memory fabric. So what grounding means? I think this is more about getting the context. think most of people have heard of context engineering. So it's related to that. It's a terminology where you try to bring data from different sources, which is required for taking a judgment. As a human, when you have to take judgment, what all references that you have to take, those all references comes as a part of grounding, which AI should also have. And otherwise, it will not be able to take the decision at human level. So that's where like policies, workflow state, other users' interactions, understanding the boundaries, understanding the exceptions, building a knowledge or graph of the knowledge, an ontology of the knowledge to understand what are the different relationships that are working together to build that information or data or knowledge that we are actually bringing in. So it has a lot of aspects. I think from the security aspect, the data should be permissible for AI to use. I think before this, the legal aspect that we are looking into, decisions which are relevant for evidence. That is generic models doesn't give you the details on the different evidences that a specific enterprise needs. So that has to be brought as a part of the groundedness. Then ontology-aware retrieval, where you understand the different information, how they are collated, how they are working together, so to take any judgment or decision. I'll take some scenarios out there, but these are some of the areas which groundedness should provide it. And what we have seen, groundedness is the most reason for most of the AI systems to fail, because they are not able to bring the data in a right state, in a recent state, and in an accurate state. And again, if you look into the top flow of it, So we get the data from enterprises. It's a typical what we use in our platforms. We retrieve, we rank it, we filter and validate, then link the entities of the relationships, compress and context. This is very important because in LLM world or AI world, context, managing the context is very important because larger the context, more the cost, more the hallucination aspect will come into picture. And at last generating a decision packet, which is what we say will serve as our reasoners. So that is the which is an kind of a summarized, grounded data which reasoners use for their reasoning or taking the decision. Okay, now coming to reasoner. So this is an important aspect because enterprises have different workflows, processes. One reasoner doesn't work in place. So reasoner is nothing but is an component of an AI which thinks through the different logic or which applies the logic to build an recommendation or judgment. So there are many reasoners which or types of reasoners which can be used. Different use cases requires different reasoners. So when we go to something like ChatGPT or Cloud or DeepSeek, they have certain reasoners which are defaulted, which works in default cases. But when we talk of enterprises where we are going to the actual judgment, those doesn't work for all the use cases. So we have to be choosing on what kind of reasoners should be taken for what kind of use cases. Something like prompt based, which I think everybody uses when you do and chatting. It's a simple, it generates fast, but it doesn't suffice to the data that we are actually looking for. There are certain design patterns out there like chain of thoughts, trio of thoughts. Those can be used, which helps you in optimizing the prompt-based reasoners. Then we have neurosymbolic. Why neurosymbolic is, again, neuro is more on the what LLM does or generative AI does. And symbolic is required here because deterministic part is very important for us. So whatever neuro is generating or the typical prompt-based reasoner is generating may hallucinate, may not be deterministic. It may not generate the same output every time you are asking for the same question. And that's where the neurosymbolic reasoners comes into picture, which takes care of a kind of a hybrid of applying certain policies on the output of what your prompt-based system is generating, so that your responses are repeatable and it's deterministic. So we cannot have cases where, for example, you are going for a loan approval, the same loan data is getting unapproved at one time, another time it is getting approved. So it has to be deterministic for the enterprise systems to work. Then again, supervised fine-tuning and reinforcement learning-based reasoners. These are actually kind of an advanced use cases where you want to have your own tuning of the reasoners using your SLM models or small language models. And you also are building your own reinforcement learning-based approach. And this is where the things start complex, and this is required for taking the system to the complexity or achieving what we are trying to do with enterprises. And last but most simple is policy-based, where you have defined policies and based upon that reasoner understands. We can say it's more like a rules, but reasoners provide little bit context into it. It understands, again, due to the natural language understanding, it understands where the entity should fit into what rules, and that based upon that recommends. I like to go a little bit on the what RL-based reasoning or reinforcement-based reasoning is. So in a typical reasoner case, what we use, the reasoners gives you output based upon what you are actually asking. In case it doesn't understand what you are trying to correct it, especially in case of enterprise use cases where your subject matter expert is very important here, who gives you the input, feedback on how the reasoners is behaving. And those feedback should go back to your model or reasoner to understand how to improve the system. And that's where the reinforcement learning based reasoners are very useful, uh, where you can retrain your reasoners with the feedbacks that are back feedback that you are getting from the SMEs, and make it tuned to what an SMEs think the reasoner should be generating a similar output. So, so it optimizes its reason and optimizes reasoning trajectory uh, based upon the answers it is getting. It improves the accuracy over time because it has something like verifiable rewards. So we use reinforcement learning, human feedback, and reinforcement learning verified reports, which are called as RLHF and RLVR. For some of the reasoners where we see those optimizations makes more sense. Uh, but it makes my reasoner more intelligent to take care of what it is working. We have rewards function, which upon that it says, okay, I can still optimize my things because my reward function is not giving me the right rewards. So those kind of intelligence that reinforcement learning based reasoners actually help in. So it actually from the lower flow side, it takes the task, it looks into policies and reward models, selects the reasoning model, verify, adjust, and then finally decide, and then learn back again. So that's where RL-based reasoners are very important for enterprise AI. So we are also working on, there are some research works are there, recursive language models, which helps in lot of optimization. So one of the important aspect is whatever I am talking about, there are a lot of LLM invocation happens into it. So you need to be very careful about the cost part of it and the tokens that you are utilizing. So there are many optimization that has been done in our platform, which helps you in those aspects. When to hit, where the public hyperscaler, when to hit my own SLMs, when to take it more of an in-memory cache or the cache-based implementations, those aspects. So, so we are working on recursive language model as well as recurrent reinforced learning also for these areas. Okay, coming to the memory part of it, I think this is something nowadays a lot of research and a lot of products are coming in. So typically our memories are divided, it's not a simple chat cache kind of thing. We have divided into multiple layers of memory. A short term or session memory, which we say, then episodic, which is where the entire chat, you can say the flow is actually memorized, and based upon that summarized and again fed back. Then semantic, where actually is basically we get the data, correlated information, if there are correlated entities which are there, which comes into those part. And last is the procedural, which is more on playbooks. So where my agent understand the playbooks and based upon that works on the system. So this we say as in memory fabric, which helps one of the things that it helps is in getting more context into accuracy, and second is the cost part of it, because it caches many things. You may not want to hit the LLMs again and again for the same kind of requirements. Maybe this is the second last thing, that is orchestration. So what we have heard, maybe for a normal work, agentic AI have a lot of orchestration. So it can actually help you in building and current and end-to-end flow. But what we have observed is not complete. You need to have in traditional workflows also to get your business or enterprises use cases to be solved. So we use a combination of deterministic workflow, which are the traditional workflows, and then we have the agent execution plan. So if it's deterministic, you need to go towards workflow for the actions that is taken. If it is variability, where agents should have to take some decisions, then go towards the agentic AI orchestration. So it's a combination of both, which helps you in building the enterprise AI solution. So this is, I think, it's a very snippet. It needs it for everything that we are doing as a part of AI platform, which is what are the runtime controls, what are the data controls, and what are the operation controls. So I think we'll have more sessions around it, but this is something which has to be part of, it is mandatory. Anything that we are doing on the higher level, layers, this comes as a part of and non-functional requirement for our system. Okay, so just to end, I think I finished early, so we can go for lunch earlier. But generation is useful, agency is powerful, and judgment creates the enterprise value. So that is very important. I think when we talk of enterprise value, it has to be deterministic, it has to be realistic, it has to be repeatable, and it has to be trusted. So if I want to replace an human or a person who is working on, say, procurement, approval with an AI, they has to bring in the same reliability or same trust that you are doing on a person who is doing that for the procurement approval. So that's where AI, bringing the AI to that state, into the judgment is very important. So from the perspective of, we have the judge who looks into the ground, who reasons, who learns, and then who acts. So it gives an output, it gives an action, and it gives us decision. So this is what the judgment AI is, or we say as in going towards AGI. AGI is still far away, but when this reaches to the level where it comes to equivalent to what human intelligence can do, we say is an AGI. And since it is trying to go towards that, that's we say is JaazX platform is an AGI platform that we are targeting to work on. Okay, I think at last we are hiring. I think this is from the HR side. So anybody interested who are interested in working on advanced AI, not a basic AI part of it, please connect with our HR team. We have multiple groups as a part of Sai group who works on very interesting AI use cases. They will be, HR will be very happy if we get some good people into our company. Thank you. Any questions? Yeah.
In the early days for building out models, having generative AI be productive, there was a lot of investment in GPUs and infrastructure and stuff, right? So now to get to this stage and at an enterprise level to become judgmental through AI, what is the investment we are looking for? What is it physically?
It's an interesting question. See, what we feel is the basic infrastructure part of it will become commodity as we move forward. The different research that is going on, like quantum computing and all, this cost will come down a lot. So where we have to focus, I think that's where the AI conclave, which we recently concluded, also said is we have to focus on the application side of things. And that's where it comes in. From the GPU side of things, the cost of the infrastructure, yes, is still there. It is getting down a lot because now it's in bulk of companies which are actually building it. In fact, India also will have its own data center for that. The focus is more on the perspective of the application side of things for our company. So yes, cost and its optimization part that we have to, we don't want to hit every time GPUs or LLMs as such, because we can do a lot of optimizations at our end, so that minimizes. And that's a very important aspect. When we started, our costs, means we actually are an horizontal platform, but we took very strict compliant domains to validate our platform, which includes financial domains like mortgage or commercial lending and all. The problem is when we started, the cost of per loan processing was very high. Now that was a first area that we targeted, whether we can reach to the judgment output that we are looking for. If we are able to reach, then we started optimizing. So that's where the optimization of the things start coming. And I think one important thing that I said is system design is very important. It's not about model problem also. So you have to design your system so that it brings you a return on investment. It shows me it's not only about time to market, it's also about the cost that you're spending on it. So that's where the system has to be designed properly to take it to the that optimized.
There have been going lot of work in enterprise tech as compared to consumer tech because of willingness of corporations or enterprises to spend as compared to consumer tech where there is less
Yeah,
of
return on investment is very less. Yes. Yes, so I think that's a very good point, and that's why we are focusing on this. We are not focusing on an end consumer kind of use cases. We are focusing on the enterprise use cases. See, the cost of having uh, not replacing, I'll say augmenting an human with AI is multifold. For example, in this case, I'll just give an example. Take an example of a domain, say mortgage. When a loan you apply for, a user provides you documents. The entire flow where the loan processor comes, loan officer comes, underwriter comes, it easily takes around 5 to 10 days for getting all the documents processed, understanding whether documents are right or not, what is the risk strategies. There are, say, around 108 such rules which are there. For any person to go and work on it, it takes at least 10 days to process that. And here AI comes in. AI comes in and says, okay, no, this is all I can do for you. I will analyze the document, I will recommend, I will provide my judgment. You go and review it and see whether it is right or not. And once the AI starts developing that confidence, it goes to the place where it's actually auto pilot actually. It can do those things. So we observed that it's actually, we are able to process a loan within few hours because we have to interact with multiple third parties, which AI itself goes and does interact it. And the cost saving is at least, I think, 100x what we are getting from AI and what you do within people in the same place. So the only thing is there has to be continuous evaluation. What is the accuracy that you are getting by the AI? So it has to be trusted. That's very important. The trust has to be there. You have the clear lineage of how that trust is created, how that decision is created. Anybody wants to come and see anytime, they can be able to see those lineage. Plus the trust aspect means the accuracy part of it has to be very similar to what human has doing. And one important aspect with human minds is that we deal with ambiguities very good, easily. We see, okay, these two documents, okay, I will decide on one of it. For AI, it's always based upon the evidences that it has. So sometimes it gets ambiguity. And then that's where the reasoners, which takes the human feedback, comes in. So in those cases where we say, okay, we are not confident more than say 95%, the users pitch in and say, okay, no, should be like this. And those all cases are handled in our platform. So once users pitch in, the AI learns back from it and says, okay, this kind of use cases, should be the scenarios. That's where, again, learning and relearning is very important from the AI perspective or this kind of solutions perspective. Yeah,
So one question.
On time.
One question.
Yeah.
So there's a recent paper called Agentic Context Engineering where they're exploring the similar things that you mentioned in the presentation. So are companies using that particular approach?
So context engineering is now an old concept in AI world. Okay.
No, there's some new one called Agentic Context Engineering.
So basically what I am saying is a grounding, it has the context engineering also inbuilt into it. Okay, so context engineering is more like where you bring resources, you bring policies, you bring data, and you try to provide a context. Earlier it used to be agentic memory. Now it has gone to context engineering because it has more broader aspects comes into picture. So it has the ontology, means which is the relationship between the information and all. So the grounded part is something which is coming from context engineering, but it is little bit advanced than that. So context engineering is solving some problem for us, but there are other problems also which we are trying to solve with this. So we have the context engineering as a default as a part of our platform. Thank you. Any other questions? Yeah. Thank you everybody. Thanks for your time and have a nice lunch.